Hi, welcome to our pre-calculus topic today, proving an identity using fundamental trigonometric identities, problem type 4. So as we said, step by step, the problems become a bit more complicated. You have to see a bit more in advance, and once again, the suggestion is to do this thing on paper first and then come here and here apply one rule at a time. So I look at this. So I have a power 2. Here's the same thing with power 1. So as if one of these powers has to be cancelled. What does it cancel with? With something in the numerator. Well, cosine square doesn't straightforward cancel anything down here, but I think about a trig identity, the Pythagorean identity. Instead of cosine square, I'm going to write 1 minus sine square. So I'm going to use a fraction here, 1 minus sine square of x, and in the denominator we have parentheses 1 plus sine of x, the whole thing squared. Okay, now we need a algebra step to simplify. There was a identity we used quite often. If you have a difference of two squares, how can you write it? As you can write it as a product of difference and the sum. Let's just go ahead and explain it here. So that's in this identity in reverse. If you have this, you can go to the left hand side as well. So a squared minus b squared, difference of two squares, is the difference of the numbers times the sum of those two items. So why is that of relevance to me here? Because when I do that factorization in the numerator, one of those factors is going to cancel the denominator. Let's go ahead and do that. Please select the rule. I forgot to say, okay, we applied the Pythagorean. Okay, next, validate, move on. So numerator, again, we have a fraction. Let's make our fractions so that it's a little bit easier. Minus sine of x, and then, well, I didn't need it. Well, 1 plus sine of x. Denominator is parentheses 1 plus sine of x squared. So all I did was algebra. Next, I'm going to cancel the two common factors here. So let's make our fractions. I'll have 1 minus sine of x in the numerator. When I cancel this second parentheses with the parentheses in the denominator, I'll just have 1 plus sine of x. So all I did was, it was algebra. And then validate. Well, I guess that's all we wanted to do here. There's more to do. We are going to come to some new identities. So expect the problems to become more involved. Let's see. Well, cannot see them here. Let's go to another one. So as I was mentioning, our identities are expanding. So other than the basic ones that we have, we also have evaluation and sum and difference. I'll be explaining that when we come across them. So secant of x plus 1 squared over tangent square. Let's remove this. You see that one factor of secant plus 1 is same as the factor on the right hand side, means one of these powers cancelled with something in the denominator. So how can I arrange for that cancellation? So I need something about tangent square of x. So what's available right now? Well, our Pythagorean identity, you remember tangent squared plus 1 was equal to secant square, and therefore tangent squared is secant squared minus 1. So let's go ahead, make a fraction here. So I have parentheses secant of x plus 1 squared. Oh, what was that? Denominator. What are we using here? Pythagorean. Oh, Pythagorean. Where does tan show up? Tan squared. Making replacement for tan squared, secant squared minus 1. So that is what we are going to use here. Secant square of x minus 1. So apply Pythagorean. Then, just as in the previous one, we factor the denominator. So I have secant of x plus 1 squared over secant of x minus 1 times secant of x plus 1. Okay, I factored the denominator. It's the difference of squares, called difference of squares. So what did I do? I just did algebra. Now one of these factors cancel, and what is left is exactly what we want over there. So validate, and then make our fraction. Numerator secant of x plus 1 is plus 1 is left here, and secant of x minus 1 is left in the denominator. And what rule did I apply? I just did another algebra, and then I should be home. So it says your proof is complete. Let's see if we get anything more interesting. Okay, that's pretty much like what we have done. So I leave this one to you, and we might have a lecture on sum and difference identities and where they come from. That would be a bit more interesting than the problem that we have been doing over and over again. Okay, so until next time, good luck and God bless.